Good morning, dear students. My name is Ferhan Mazher, and today is 30th November 2020. The day is Monday. Right now, I am with the 10 Cambridge class, and we are studying Physics 5054, and we are studying the chapter by the name of Sound. And today, we are studying about an experiment in which we study that the sound waves reflect. So, remember this idea that the sound, when the sound travels, the sound propagates. The sound always travels with the help of, you know, a longitudinal wave. The sound travels with the help of compressional waves. Longitudinal waves or the compressional waves, they comprise of compressions and the rarefactions. So, as you know, we have studied in the light, we have studied in the waves chapter that the waves they can reflect from a barrier. For example, in the chapter of light, we have studied that when we place a mirror and we take a beam of light, and we saw that in the chapter of light, that the light is reflected from the mirror. And we have also studied that the light always obeys two laws. And one of the laws was very important, that was that the angle of incidence and angle of reflection, in the case of light, they are always equal to each other. So light is also a transverse wave and it is reflected. In the same way, the sound waves, which are compressional waves, longitudinal waves, they also are reflected if a solid body comes in their path. What happens? The sound waves strike with that surface and they are reflected back. So, for example, you must have experienced that, uh, there's a word we say echo. Have you heard this word echo?
Yes, sir.
Okay. So when you talk or when you speak, and what happens? The sound waves are coming out of your mouth, and if there is a wall in their path, and the sound waves will bounce back from that wall. The sound waves will be reflected from that wall, and when you hear that your sound again, we call it echo. When you hear that reflected sound, the sound waves which are
That
reflected
back.
from a rigid surface, those are called, that is called echo. Have you heard
Okay.
about the word echo? I mean, do you understand now echo?
Yes, sir.
Okay. Now, uh, we have to, this is also from exam point of view, very important. And sometimes when you will be practicing your papers, you will see that sometimes this experiment comes in the paper, sometimes in the ATP paper, and sometimes even this comes in the theory paper, that you have to describe an experiment which shows that the sound waves do the reflection process. Okay,
Sir,
and
when
the
will we begin
experiment,
ATP?
sorry,
Sir, when are we going to start ATP?
this is a ATP.
Okay, sir. I'm sorry,
The
sir.
experiment, the bell jar experiment is ATP. This is also an ATP. Okay.
Okay, sir. I'm sorry.
Okay. So now the experiment is very simple. You see, we have the material which we are using. We have a block of the plywood. Here you can see that block of the plywood. That is the rigid surface which will be used for, from its surface, the sound waves will be reflected. We have two pipes. Here we have one pipe, you can see, and this is the other pipe. They are made of cardboard tube. So they are made of cardboard, and these are two pipes. You can say. And what I have done, we have taken a horizontal table, and on that horizontal table we have placed a white paper, as you can see in the diagram. On that horizontal table, we have fixed a paper, white paper, and we have here. This is a soft board. Soft board is placed here, and there's a gap between the plywood and the soft board, and I have placed a soft board here, and I have placed one pipe in this direction, like here. You can see in this diagram, we have placed a pipe, and in that pipe, I have placed a clock, and that clock is ticking. So it's producing basically sound. The clock is clicking, is producing this sound, and so the clock is basically the source of the sound. And I have put that clock at this end of this pipe, and obviously the sound waves are produced, and those sound waves will be traveling in this pipe, and they will strike, they will collide the plywood at this point, and from this point they will be reflected. Okay, so on this side I have another. Shahjahan, you have shared your screen.
No, sir, I did not. But let me cancel it. No, sir, I haven't.
On the main screen,
Sir, I haven't.
you haven't. Let me. You lost your network.
Sir, I will leave it.
There's a problem. There's a problem. There's a problem with the internet. Let me fix this. Oh, we are working online, so there is always chances of
So is it okay now?
something happened. Yes, yes, it's good. Uh, Sorry, due to internet, something happened with the internet. Okay.
No problem. No problem, sir.
Okay. So now you see the sound waves which are traveling through this first pipe. Here they will strike the plywood, and from here the sound waves will be reflected, and they will go in this direction. Okay. So what you will do, you will take this pipe and you will move this pipe like this way. You will move it this way. You will move it this way. On the other side, on this side of the pipe, you will have your ear, and you will move the pipe clockwise, anti-clockwise, and you will find a point where the sound will be loudest. Okay, this point is very important. You see, on this side, you will be holding this pipe, and your ear will be near this end of the pipe, and you will move it clockwise and anti-clockwise, and you will be looking for that point where the sound of the clicks of the alarm stopwatch will be loudest. Wherever you hear the sound of the clock loudest, you will stop the pipe there. Then we will mark on the paper the positioning of this pipe and the positioning of this pipe. Okay, you can put a dot on the paper on this end, you can put a dot on the paper on this end, you can put a dot on the paper on this end, and you can put a dot on the paper on this end, and then you will remove everything. Then you remove everything. Then you join these two dots where, and join them with a straight line until that straight line joins the plywood. It meets the plywood wherever the plywood was, and then join these two dots for this pipe with a pencil and a scale with a straight line. Join them till it joins the plywood. This line which will be on the paper, that will be known as the incident sound waves, and this line will be representing the reflected sound waves. At this point where they join each other, where the plywood was, draw a normal. Normal, will be and a line which will be making 90-degree angle with the surface of the plywood. Then, with the help of a with the help of a protector, measure the angle between the incident ray, incident wave, incident sound wave, and a normal. That will be the angle of incidence, and measure the angle of reflection between the reflected sound waves and the normal. That will be the angle of reflection. And to your amusement and to your wonder, you will find that the angle of incidence and the angle of reflection, they will be equal to each other. So this is an experiment in which we will be able to prove that the sound waves undergo reflection, and that the angle of incidence and the angle of reflection in the reflection of the sound waves, they are equal to each other. If you want to do it again, change the positioning of this pipe. Maybe you move it towards this soft board, or maybe away from the soft board, and then by moving the other pipe clockwise or anti-clockwise, find the point where the sound is loudest, and then again mark the positioning of the pipes, and then join them with the pencil and the scale with the plywood positioning, and again check the angle of incidence and angle of reflection. The angle of incidence and angle of reflection, they both will be equal to each other. By doing this experiment, we are able to show that the sound waves undergo the process of reflection, and the angle of incidence and the angle of reflection is equal to each other. Do you understand this experiment?
Yes, sir. So I hope it's
Yes,
like the light one, because in that thing we have the incident ray and the reflected ray to be equal, the angle of them.
See, uh, this experiment is kind of similar to the reflection of the light.
Yes, I was asking the same thing.
And yeah, and as in the reflection of the light, the angle of incidence is equals to the angle of reflection.
sir.
So, my dear students, I hope that you have understood this. And whenever this will come in your paper, you will be able to write this experiment. This comes in ADP. So, thank you very much, Ji.